In this video, we will be doing some inventory management problems. These are likely part of your homework on inventory management. So we have two scenarios. Astro appliances scenario, we have to calculate a bunch of parameters, and then we are going to do well, actually it's the same scenario for most of the questions, where you have to do QR, continuous review system calculations, and then periodic review system calculations. And then we have a question on one period models that we'll talk about at the very end in the concession stand at Ford event scenario. So let's get started. So here's some data. So I recommend just copy paste or type this out into Excel. So we need appliance distributor. We'll open certain days of the year. We need so we have this product, countertop mixer, and we're going to set up the inventory parameters for that. Question 1 is, if we use a continuous review system, what should be the order quantity queued? That will be the order we place with our supplier or the manufacturer to give us that much quantity of the product when we are short on inventory. Okay, so we need to get the demand characteristics here. So demand D is going to be 100. That's your average daily demand, small d. Okay, we can convert it to annual demand. Annual demand is big D. Okay, and that is going to be, we are open for 260 days a year, which is 5 days per week times 52 weeks per year. Just multiply the daily demand by that. So this demand for 5 days a week times 52 weeks, we get 26,000 units. This is all in units of that appliance. Okay, so we have the standard deviation of demand, SD, standard deviation of daily demand, which is 30. What else? We have lead time, holding cost, ordering cost. So we need these holding cost and ordering cost for the Q calculation. So we get ordering cost S, that is $35 per order, and then we have holding cost, okay, which is $9.4 per unit per year. 9.4. Oops, this is going to be capital H. $9.4 per unit per year. Okay. Now keep in mind, okay, that sometimes the holding cost is given as a percentage. So an alternative way the problem could be given to you could be, the problem says the appliance costs $40 or let's say $80 to acquire, or supplier sells it for $80 to us, either way. And somewhere else in the problem it might say the holding cost is 20%, something like that. Okay, so then in this case, C, the item cost will be 80. Small h, the holding cost percentage will be 0.2, not 20, because 20% means 20 over 100. You want to convert the percentage on a 0 to 1 scale. So 10% becomes 0.1, 20% becomes 0.2, 25% becomes 0.25, 32% becomes 0.32, and so on. Just divide by 100, so 0.2. And then capital H in that case would be equal to 0.2 multiplied by $80, or $16 per unit per year. Okay. And so a lot of times you're given holding cost like this. You're given the value of the item and you're given it a percentage, and you multiply the value with the percentage to get capital H, okay, which is the holding cost per dollar per unit per year. This small h of 0.2 is called dollar per year. It is if you have inventory worth $1, you pay 20 cents on it to hold it for a year. This one is talking about if you have one piece, one unit of the item in inventory. So if you have one of this appliance, this countertop mixer in inventory for a year, you spend $16 keeping it safe in a warehouse and all of that, right? And so this is dollar per dollar, and this is dollar per unit. And so to go from small h to big H, just multiply small h by the item value, the item cost, how much money you spent to acquire the item, basically. That's C. You multiply that by the small h to get big H. So just remember this. This is extremely important, because sometimes you're given capital H, dollars per unit per year, but many times you're given small h as a percentage or as just $0.2 per dollars per year. So it might say, the holding cost is, let's say it says $0.22 per dollars per year. That means that small h equals 0.22, because it's dollars per dollar. It's not dollar per unit. So it's small h. It's not big H. Okay, big H is always dollars per year. So this is your big H. Okay, so remember this. The difference between small h and big H in holding cost. So we are given a holding cost. Now we have to find Q. And the optimal value of Q, which we sometimes call Q star or EOQ, economic order quantity. Actually, let me write this. Ordering quantity, which can be called Q star or can be called EOQ. EOQ. Okay, and we can compute that. So let's go to our slides. Okay, and here is the formula on slide 14. Our EOQ says 2 times D times capital D, which is annual demand, times S, the ordering cost, divided by capital H, which is the holding cost in dollars per unit per year. So notice this formula uses capital H. If the question gives you small h, you have to convert it to capital H to use this formula, right? Okay, so let's do that. So we have square root. So equals square root 2 times capital D is right here times S divided by, okay, H 9.4. Now this would work in this case because there's no plus sign in the numerator. But to be careful, I always recommend students to do this. Put the numerator in closed brackets. So it's going to be 2 star D star S. So the numerator is completely calculated, and then once it's completely calculated, divide by the denominator, the bottom part of the fraction, and put that in brackets as well. This will make sure your calculation is safe all the time, because if there was a plus sign in the numerator and you did not put these brackets, you could make a mistake, because Excel follows a certain order of operations. So there's a plus sign here. It'll do the C6 over C7 division first and then do the addition. It will not do the addition thing first. So you want to calculate all of the numerator here, then divide by the denominator. So just putting some extra brackets to make sure it happens in the right order. Okay, so that's 440.019. Okay, now if we go to the problem, we are set to round the answer to the nearest whole number. Okay, so we are going to round it using the round function. Round this number to 0, places after the decimal, because a whole number has nothing after the decimal. 2 is like there's nothing after the decimal. 2.1 has 0.1 after the decimal. So we just round it to 0 digits, which is after the decimal. So our answer is this, 440. So this is going to be our EOQ quantity right here for the first question. Okay. Okay, now the second step, we have to find the reorder point R. Okay, we are given the lead time, so we're going to need to use the lead time. So let's move this stuff down and put all of our data in one place. That's what I prefer we do. Put all the data in one place with the units. Lead time is 3 days. CSL, cycle service level, CSL is 0.92. 92% is 0.92. This is going to give us a z-score, and we can convert it into a z-score here because we're going to have to use the z-score. And again, if you go back to your slides, when we talk about the QR system and we talk about the reorder point, you will see that I give you the formula to compute Z in Excel. Okay, how do you get the Z value? And I give you the reorder point formula right here, which includes the Z. Okay, so if you go here, use this formula in Excel, norm.s.inv, you can compute Z. Norm.s.inv of the cycle service level will gives us the Z score. So that's to the cycle service level. You can represent the cycle service level as a probability, which is the CSL, or as a Z score, which is this number. They're both representations of the cycle service level. Okay, now to calculate the reorder point, let's see, to calculate the reorder point, we got all the information here. Yep, we got the lead time. And we go, okay, so we have to figure out which scenario we're facing, because to calculate the reorder point, you need to calculate safety stock. Okay, safety stock is this term right here, Z times sigma DLT. To calculate sigma DLT, which is standard deviation of demand during lead time, it's going to be one of the three rows here. Okay, which row it is depends on your situation. So constant demand, constant lead time means sigma DLT is 0, which means safety stock is 0. So you just do the rest of the formula. A variable demand, constant lead time is going to be this formula, which is what we have. How do I know we have this? Because I'm given sigma D or SD. I'm given standard deviation of the demand in the question, but I'm not given any standard deviation for the lead time. No standard deviation provided means we assume that quantity is constant, because if it was not constant, the question should have given you the standard deviation for that quantity. Okay, and then variable demand, variable lead time situation, you have both things variable, and you have to calculate sigma DLT using this big square root thing, and you multiply by things inside. The lead time times the standard deviation of demand squared plus the average demand squared times standard deviation of lead time squared and square root of the whole thing. So we're going to use this formula, standard deviation of demand times square root of lead time, in our calculation. So we'll do sigma DLT. Okay, that's going to be standard deviation of demand multiplied by square root of the lead time. Yes, I'll put a bracket at the end. Okay, then our safety stock SS is Z times sigma DLT. So just Z multiplied by this quantity here, this one we just computed, is going to be your safety stock. So this is this term, Z times sigma DLT. To safety stock, we have to add the average demand times the average lead time. Okay, so then reorder point, ROP or R, is going to be average daily demand, D, this 100 times the lead time plus the safety stock, which is right here, the cell right above this, right? So we get 373.01. And now if I look at this, round your answer to the nearest whole number. So again, we do equals round this number to the nearest whole number. If I said round to 2 decimal places, you could do something like this, right? If I say round to 3 decimal places, you put comma 3, that's to 3 decimal places, right? And then to see them, you have to just do this, right? And if I say, round to a whole number, then this means 0. There's no decimal places. So that's 373. Okay. If the distributor uses a continuous review system, what is the total annual cost, holding cost plus ordering cost? So the total annual cost of this system is also the formula is given right here, slide 29, total relevant cost for QR system. So total relevant cost in dollars per year is going to be this. This is going to be your ordering cost, this one D over Q times S, and this whole thing here is going to be your inventory holding cost. Part of inventory holding cost is this again, Z times sigma DLT is your safety stock. So safety stock plus Q over 2, the whole thing added together times capital H will give you the holding cost, the total holding cost per year. And then this term right here will give you the ordering cost. You add both of them together to get the total annual cost. Okay, so let's do it. Ordering cost. Okay, that's going to be capital D, so that's annual demand, divided by Q. Q is 440. We're going to use the rounded value because that's the answer we put in. Okay, times S, which is the cost per order. Okay. D over Q gives you the number of orders you place in a year. So 26,000 over 440 is about approximately how many orders you place. Each order costs you 35 times 35. That's your ordering cost in dollars per year. Okay. And this is your R value, the order point value. And I guess safety stock is important too. We can make it blue too. Safety stock is right here. Okay. Then we need the holding cost. So that's going to be Q over 2. So Q over 2 plus the safety stock, the whole thing multiplied by capital H. So that's this much. Again, that's dollars per year. So total cost is just going to be the sum of the holding cost plus the ordering cost. That's again going to be dollars per year. And 2 decimal places, so that's already to 2 decimal places. And you can do this to look at, it's 473, so it's going to be 47. So 4822.47. Okay. Okay, so now question 4. Assume we're using the continuous review system, so we're using this Q and we're using this R. Okay, to manage the inventory. On-hand inventory is 4. So this is on-hand inventory. Okay, excuse the spelling. Is 40 units. Okay, open order. So open order is 440 units. Okay, there's no back orders, so back orders is 0. Okay, so then we can find our inventory position IP. Inventory position IP. Your inventory position is going to be the on-hand inventory plus orders you have placed but not received, which are also called open orders. Open orders are you've already placed the order with your supplier, but the supplier is shipping it, waiting for you. You're waiting to get it. Minus any back orders. So back orders are customers ordered this, but you didn't deliver it last time. So as soon as new inventory comes, you have to fulfill the back orders first. So that is your inventory position, which is 480. Should a new order be placed? So we compare the inventory position with our reorder point. Okay, how does the reorder point of 373 compare to inventory position of 480? Inventory position is more than the reorder point. 480 is a bigger number than 373, so we will not place a reorder. If inventory position IP was equal to or less than the reorder point, then we would place a new order and we would place an order for 440 units. Okay, 440 pieces of the appliance. And so because IP is bigger than R, so order 0 units, which is basically no order, because IP is bigger than R. Inventory position is more than the reorder point. So you put 0 here. Okay, let's go on. Now the operations manager at Astro Appliances is considering changing the inventory management system to a periodic review system. What period P will give approximately the same number of orders per year as using the EOQ quantity in the continuous review system? Okay, so let's do that. So let's call this our QR system calculation. And I'm just gonna make a copy, okay, and call it my periodic review PT system. Okay, and in my PT system, question number 1 is what is let me delete all of this. What is P? Okay, so I can still use the EOQ to find P because that's what's basically telling me to do, right? And the safety stock would be different, so this all needs to be deleted. but this is all this data from the question, so it's the same data. Okay, now if you go to your inventory management part 2 slides, okay, it just tells you what the what the P means, okay, and then it tells you how much to order, okay, how to set the period P, this one right here. So time between inventory reviews P is sometimes set based on convenience or transportation schedules, but the question does not tell us to do that. Another option is to set P to be the time between orders that is implied by the EOQ quantity. Okay, so now remember that our lead time is in days. So TBO, time between orders with that EOQ quantity, okay, is going to be the EOQ quantity divided by annual demand in terms of years. So time between orders is 0.061 years. Okay, but we need TBO in days because the time units here have to match the time units of the lead time. Okay, and so what we would do is we would convert this years into days, so TBO days. And when we say days, we always use working days. So how many days a year are we open? 5 days a week times 52 weeks. That's how many days a year we're open, times how many years our TBO was. If TBO was 1 year, we'll get 260 days, right? So 0.016 years will translate into some days. That becomes 4.4 days. Okay, and so we're going to set our period P equal to 4.4 days. However, I believe the question tells you to round it to the nearest integer, so you will just get 4 days. So it says round your answer to the nearest whole number. So we do that, and so that is our period between reviews. Every 4 days we're going to recheck our inventory position and place an order if required. So this is our answer, and this is not the answer because you have to round it to the nearest integer. Okay, so you get time between orders using the EOQ and the annual demand. EOQ or annual demand is 0.01692, which is the time between orders in years. Then you convert it to days by multiplying by the number of working days you have in the year. You get 4.4. Then the question forces you to round to the nearest whole number. If it was 4.5 or more, it will round to 5. But because it's 4.4, it rounds to 4 days. So your period P is 4 days. If the distributor uses product review system, what is the target inventory level T? Yes, again, we refer back to our slides. Okay, in the slides, here is the formula on slide 6, inventory management part 2. Target level T is the average demand daily or in the same units as P and L. If P and L are in weeks, this will be weekly demand. We have L is 3 days and P is 4 days, so P plus L is in days, so this will be daily demand. The units, time units have to match up. So demand times P plus L. This D is never the annual demand. It's going to be daily demand or weekly demand, something like that. Times P plus L in the same units, plus this is our safety stock, which is Z times sigma P plus L, and sigma P plus L is one of these 3 options. If it's constant demand, constant lead time, it's 0, which makes this whole term for safety stock 0. Otherwise, it's if it's variable demand, like in our case, standard deviation of demand is 30. We are given that, and this constant lead time. How do I know there's constant lead time? Again, because there's no standard deviation given for the lead time. If there was, I would know. I would use this formula right here. So we'll be using this formula, okay, to find sigma P plus L, and then we can find safety stock, and we can find the target level T. So let's do that. So we'll do we'll do sigma P plus L. Okay, that is going to be standard deviation of demand times square root of L 3 days plus P, or P plus L, doesn't matter. 3 plus 4 or 4 plus 3, you get the same answer, right? So 4 plus 3. So 30 times square root of 4 plus 3. I got 79.37. I'm not going to round intermediate calculations, so don't just round it off. Now I'll do safety stock, SS. That's going to be Z times standard deviation, this cell right here, standard deviation of sigma of P plus L, standard deviation of demand during the protection interval, which is P plus L. Okay, so I get that. Now I can get the target value T. Okay, if I go back to my slides, the formula is demand times P plus L plus safety stock. So we do demand is 100 small d times P plus L. So again, 3 plus 4. Okay, plus the safety stock, and that's 811.52. Let's see what the rounding instructions say. Round to the nearest whole number. So again, I am going to do equals round this number. Okay, and I get 812. So this is my target inventory level T. Okay, 812. Okay, so P and T are the two parameters of this system. So I found P to be 4 days and T to be 812. So both of them, you have calculated the parameters of the system. Now we can calculate the annual cost. That's again going to be, we're going to have an ordering cost component and a holding cost component, and then we're going to have total cost just like last time. And all of these will be dollars per year, dollars per year, dollars per year. Okay, so we can find the formula again. We go back to our slides. Okay, here is the formula. Total relevant cost dollars per year. This part right here is the holding cost. D times P over 2. Remember in the previous one we had Q over 2. So this time that's going to change a little bit because we're not ordering size Q all the time. D times P is our average order size basically. So that over 2 plus Z, this is this Z sigma P plus L is safety stock, which you already calculated. You add this to this, multiply the whole thing by H, that's your holding cost, and capital D divided by small d times P is going to give us approximately the number of orders per year times S. That's going to be your ordering cost. Okay, so let's do ordering cost first. That's going to be capital D divided by, okay, I'm going to use brackets because I have two things here. I'm going to take small d multiplied by P. Okay, small d multiplied by P. The whole thing is dividing the capital D. That's number of orders per year. So we have 65 orders per year. You multiply the whole thing by S. Not S as safety stock, but this S, the cost per order, and you get ordering cost to be 2275. Okay, now let's do the holding cost. So again, here's the formula: D times P over 2 plus safety stock, and the whole thing is multiplied by capital H. So we do D times P, okay, divided by 2 plus the safety stock, and the whole thing gets multiplied by capital H. Okay, then we sum these two things up and we get the annual cost, total annual cost of this using the system in dollars per year. And then we can just check the rounding instruction. Round to 2 decimal places already is, and so we get 5203.33. Okay. Okay, let's do question 8. Okay, question 8 says, so if you were using this PT system with a period of 4 days and a T of 812, on-hand inventory is 40. So on-hand inventory is 40 units. and then we have receipt of 440 mixers is scheduled. So this would be the same thing like we had here, which is open orders. Scheduled means we have placed an order, so we can call it scheduled receipts. We can call it open orders. It means the same thing. That this is stuff you have ordered. We don't have it yet. It's on the way, or it's going to come soon. That's 440. Back orders are 0. No back orders exist, so inventory position IP will be 40 plus 440 minus the 0, or 480 units. How much should be reordered? So whenever we do a check and we find the inventory position, the reorder quantity Q, the order quantity, is always that number that when you add it to the inventory position, you go all the way up to 812. So 812 is up high, 480 is like below it. So what can I add to 480 to make my inventory go up to 812? So it's basically simply just T 812 minus 480, the difference between the target value and the inventory position. So we need to order 332 units. Okay. Okay, and now we are going to do one period decision models with the last two questions. Okay, so you're running a concession stand selling Thunderbird racing jerseys at the outdoor conclave for owners of collectible and classic Ford cars. And so you have jerseys are purchased from Columbia Products for $40, sold during the event for $75, and so on. So let me show you in the slides where we talk about this. So you go to this section here on inventory management part 2, inventory for seasonal items, 1 period decisions. Okay, that's also called the news vendor model. Okay. And here you see that you need CS, which is C shortage, and C excess, which is CE, and then everything else is based on these two numbers, where you have the optimal service level, CS over CS plus CE, and then you have to do some probability calculations using norm.inv. So let's do that. Let's calculate cost per shortage and cost of shortage. CS per unit. If there's a 1 unit of shortage, what's the cost, and cost of excess for 1 unit? Okay, so CS is easy. It's revenue minus cost. Okay, so, and this is question 9. So we have cost of shortage, CS. That's going to be how much I sell my shirts for, the revenue. They're sold for 75, minus the costume. It cost me $40 to get the shirt. That's basically your gross profit that you miss out on if you have a shortage, because shortage means there was demand, you didn't have the inventory to sell. Okay, so per unit of shortage, I lose $35. Let's do cost of excess, CE. That's if you have too much stuff. So if I have an extra jersey left over, which I've paid $40 for, they can be returned for a refund of $30. So my salvage value that I get back is $30. Okay, and so my cost of excess will be how much I paid minus the salvage value of $30. So $10. So any extra jerseys cost me $10 because I paid $40 and I only get $30 back. I'm only able to recover $30 of them. This happens because either the supplier has a restocking return fee, so you lose some of the money and your salvage value is less, or you have to sell it at a discount to some other shop or discount retailer or somewhere else in the world, and that discount and transportation cost will reduce your salvage value from what you paid for the item. And so, you do that. What you paid minus the salvage value, that's your cost of excess. Okay. Now you need your optimal service level, which is the CS, cost of shortage, divided by CS plus CE. Okay, so optimal service level is equal to CS divided by, again, you have to use brackets, otherwise you'll see what will happen. If you do just CS over CS plus CE like this, this is wrong. The optimal service level is always a number between 0 and 1. It's a ratio. It can't be 11. It's dividing C3 by C3, which is 1, and then it's doing plus 10, which is wrong. So we have to do bracket open CS plus CE, bracket closed. You can see we got a ratio of 0.77778, something like that. Okay, so now we have to copy paste this table. Okay, and we have to find out this ratio translate to which quantity in the table by comparing this probability with the cumulative probabilities. Okay, so if you look at the slides, they explain the process for you. You basically have to calculate the cumulative probability column and then take your ratio, your optimal service level, and see where it falls in this table. Okay, and here is 0.71, which falls between 0.5 and 0.75. So we'll take the higher of the two, 0.75, and the demand in this row would be what you would order. You would order 40 in this case. Let's do the same thing, cumulative probability. So what's the probability that your demand is less than or equal to 100? That's just 0.05. What is the probability your demand is less than or equal to 200? That's 0.11, that is 200, plus the probability that it's less than or equal to 100, which is the previous cumulative one. Okay, and then you can just drag this formula down. Let me do another one for you. What is the probability demand is less than or equal to 300? That's the probability demand is equal to 300 plus the probability is less than or equal to 200. Okay, so it's this probability plus the previous one. For the first one, it's a little bit different because there's no previous one, it's just this, right? But the second one on is this plus previous. This one is this plus previous, right? Just drag it down. If you do it correctly, you should always end up with 1 in the last row. And for the first row, the probability and the cumulative probability should always be equal. And the last row, the cumulative probability should always add up to 1. That's tells you did it correctly. Okay, now in this column, okay, let's see where does 0.777 type of fall. So it's between these two numbers, right? And so because we go with the higher one, we'll go with 0.84. Okay, and look in this row to find the quantity, which is 400. So optimal quantity to order is 400 from table, because this is the case where demand has discrete levels. Demand is this, or this with certain probabilities. So we have to do the cumulative probability method to calculate Q star. Okay, so the optimal quantity would be 400. Okay, now it's the same question, question 10. Assume that instead of this distribution, this table is no longer valid. So demand distribution, which was given by the table before, okay, is now given by a mean value, mean of 350 units, a standard deviation SD of demand of 100. Okay, and it's normally distributed. It is normally distributed. Okay. So what is the optimal quantity of jerseys to order? Again, the slides tell you what to do. So if you have a normal distribution scenario, right here, okay. So for a normally distributed demand, you do this, norm.inv, service level, which is your optimal service level, and then the mean demand and the standard deviation of demand. And then this example does that for you. So you do norm.inv. If you put 0 average demand and 1 standard deviation, it gives you a z-score that you can convert to Q star by this way, or you can just directly give it the average demand and the standard deviation of demand here and be done in one step, which is what you're going to do. So what we are going to do is we're going to say Q star optimal quantity is norm.inv. The probability is an optimal service level. The mean is the mean of the demand. The standard deviation is the standard deviation of demand. And so we get 426.47. Let's check what are the rounding instructions here. Round your answer to the nearest whole number. So we do equals round this number to the without any decimal places, and we get 426. And so that would be our answer. Although, in this case, a little bit tricky. So sometimes what people will do, they'll say, okay, the 7 makes the 4 a 5. So to 1 decimal place, if you round it to 1 decimal place, okay, you get 426.5. And 426.5, if you round it to 0 digits, you get 427. But if you run it directly from here to here, you get 426. Why? Well, because the 0.47 is less than 0.50. So if you do the comparison in just one go, you say, okay, 426.47 is less than 426.50. So it's going to go to 426. That'll be correct. But some people have been taught to do it like this. They first round to like 1 decimal place and then go here. Either way, I would accept both answers, 426 or 427. Okay, so I am going to use here for 26. Okay, but if you use 427 and it marks you wrong, I'll give you the points back. I'll make sure that it does accept both answers, because this is how you would do it, and this is kind of a common way some people have been taught to accept this as well. Both are fine. It's just rounding. Okay, so don't worry about that. So that is it for the homework. So remember, we did 3 types of problems basically: a continuous review system with a Q calculation, this one right here with the R calculation. We got safety stock in the between. We got the total cost per year. We looked at an ordering decision. Our inventory position was so much. So do we order? No, we don't order in this case. Then we look at a periodic review system. We calculated P based on EOQ, because it told us there was no convenience factor involved. Just use the EOQ to calculate your P, which will be rounded down to 4 days to the nearest whole number. Then you had a T, the target level. And then we said we will order in this case because inventory position was less than T. Yeah. And then we have the 1 period decisions where there can be no replenishment. You have to decide how much inventory to stock, let's say the beginning of a day, and then only that much you can sell in the day. You may have a shortage, you may have an excess, and we use the CSCE to calculate our optimal service level. And then we use our demand distribution either as a discrete demand distribution given in a table or as a normal demand distribution given with a mean and standard deviation. We use the demand distribution to convert the optimal service level into an ordering quantity. Okay, and so that is it for this video.